Hello everyone, I am Aarti and today I will be demonstrating another project that I have been working on. It is known as Semantic Document Search Retrieval System, which uses FastAPI, ChromaDB, and Sentence Transformer. Now you might want to ask, what does the system actually does? So this system allows user to search with respect to the meaning rather than finding the exact keywords. So how is that even possible? So this system actually converts the documents or queries into vector embeddings and then retrieves the most semantically similar documents from it. Before this, I would like to show you my GitHub repo, and let us check our Git status first. So it's on main branch. Branch is up to date, and git push just to show that everything is up to date. I can show you my GitHub repo as well. So this is what my GitHub repository looks like. So I can increase the size. Okay, all of my files are there, and there are no pending commits right now. Okay, let's get back to our project structure. Now let us have a look at our project structure. So this is my project explorer. In this document folder, I have all the text file present over here. Initially, I've got like 4 sample files, but I've added a couple of more into this. Then I have the static folder, which contains my HTML code and the CSS styling as well. I have a source directory, which contains another folder called retrieval, and it consists of 5 different components. So let us go through one by one. So the embeddings folder is the embeddings file, I'm sorry. The file converts the text into vector embeddings using the sentence transformer. I have a loader file. This file reads the text from the documents directory that I have over here. Then we have the retriever file. It coordinates the loading, indexing, and searching operations. The store file, this is also known as the vector store file. So what it does is it actually stores and searches the embeddings using the ChromaDB. And finally, our main file, which contains our FastAPI endpoints, which are used for like searching as well as health checks. Now let us run the server. Upon running the server, we will be able to see our browser in our project in action. So we need to wait till the server starts for a few seconds. Okay, our server is started now. Let us open the browser. Here's our web interface. So you can see there is a search bar where I can type ML engineering. User would be entering their query into this. And let us just search ML engineering and hit enter. And here you can find all those documents which have like semantically similar meanings related to our query. Moderately relevant, we can see it in sample 3 text file. We have like other files as well, like ML model deployment, training new engineers, sample 1, and customer support process. They all have like relevant semantically similar query that we'll be looking over here. We can adjust the top K results as well. So for this, we could have like a top 3 or 5. 5 has been set as default, 10 and 15. We can also adjust the relevance of our search results. So if I increase the relevance, high relevance, and perform the search, we see that sample 3 is the most closely matched document for our query. Now, apart from this, we can also clear the results. And on the top, it shows healthy. This healthy shows that how our whole website health is there. It's showing healthy for now. The number of text documents that we have, it's actually 34. It's present in our documents folder. It has been displayed over here. Now we can get back to our project again. I have performed a couple of test cases as well, which are like unit test, integration test, and smoke test. So for this, you can close my server and we can run UV. I've been using UV a lot over here. So UV run Pytest. And this would start our testing. So while the testing continues, it is going to take some time. I can walk you through the test folder. This is my test folder, which contains all of my test files, the test embeddings file, the test integration, loader, retriever, the smoke test, and also got the test store file. Now each of these files would be tested below. So now test embeddings file has been executed and it shows 19% over here. Now integration test file is being executed, it shows 29%. The loader file, test loader file, it has showing us 48% over here. The retriever file is currently executing. We can wait, see how much it executes. Okay. So it has 78%. Now our smoke test is being performed. Smoke test turns out to be 85%. Now finally, our store file is being tested. Okay, so now we have got our test coverage results. My whole project has got like 93% of code coverage. And I have like 41 test cases and all have been passed. It took me around like 1 minute and 27 seconds. So my overall code base is following a clean code setup and clean code practices, and it also uses rough formatting as well. So we can have a look at our rough UV run, rough check, and all checks have been passed. Similarly, we can check our formatting as well. Format. Oops, sorry. This format. 13 files have been left in the reflection. I think this assignment was a great exercise in building an end-to-end AI system rather than focusing just on one component. I learned that how semantic search works in practice by combining the sentence transformer embeddings with a vector database using ChromaDB and exposing that the functionality through a FastAPI backend. Overall, this lab helped me to bridge the gap between the theory and the real-world AI system implementation, especially in the context of document retrieval and search application. So that is it for today's project. Thank you for watching.